Great stuff. Right. I think there's more people coming live as we go. This is fantastic. I think everybody's in now. Hey guys, thanks for joining our experiment today. So you're all very welcome.
Hi,
And
Tom.
that's
Not sure why my camera is not working, but I'm here.
no problem. And I, let me just mute
Hey,
this
Tom,
thing.
I'm not sure you can hear me.
Yeah, I got you, Bill.
Okay, if
So
you want me to mute, let me know if we got a lot
no,
of
it's
background
all
noise
good.
or something.
There's no background noise that I'm hearing. So I think we're good. I'm gonna hit record so we'll be able to edit this and probably put it up on YouTube again. But I'm just gonna hit record now, hopefully. Uh Actually I don't think it's gonna let me do that. Just a sec. I'm just doing another setting. But it's all going to be on YouTube anyway. So we're going to go with this. All right, guys. Welcome, everybody. Great to have you all here today. Nice to have a good turnout for our very first monthly share on the Signal group for Improvement Starts with I. So without any further ado, you all know me. You all probably know a little bit about Mark, but I'm going to hand over to Mark and let him give a short introduction, and we'll fly into the hot stuff. Okay, Mark, over to you.
Okay. I guess I'm one of the older guys here in the team. Uh, my lean background, I guess my first lean project is 1978. And shoot, I'm not sure exactly how to do the background. So I've worked as an engineer in manufacturing for many years, done production lines, done mixed model flows, done engine development, fuel systems, was an internal consultant for Robert Bosch Corporation all over the world, which kind of gave me the opportunity to hone my problem solving skills. Then hooked up with some people and we started really digging down into lean and its background and how Toyota used the TWI programs to help build their systems. And as an engineer, you kind of naturally curious. And the more I dug down, the more I realized it wasn't invented, just kind of, it didn't start in Japan. And so the other piece is I would like this to be kind of an open discussion. I'm going to do a little bit of a presentation and just let people ask me questions as we go. So with that, let me put this on presentation. I got my other screen here. Okay. Can everybody see that?
We can.
Okay. So I know, Tom, you advertise this as about improving flow, but I would really like to say, let me try to do the background about trying to organize for flow. And that's where I'm going. And I want people to understand that there's some principles and thinking behind the idea that's been around for a very, very long time, where everybody is trying to improve their productivity and make their jobs easier. And so where we are today is kind of a cumulative effect of all of their experiments. So this is also a little bit of a disclaimer. The older I get and the more research and practice I get, the more I realize I don't know what I don't know. So in spite of any of the pedigrees and links back to people, some of the earliest lean practitioners here in the States, I think I have more questions today than I did 20, 30 years ago. So one of my projects I'm doing this winter, since I can't work outside and I really don't want to travel in the cold weather that much, is courtesy of the Shingo Institute, and Rizzio and I talked about this a couple of years ago before he passed away. I've got copies of most of his father's books, but it's all in Japanese, and less than half of his books have been translated into English. And I was curious, kind of the thinking behind Shingo, especially because Shingo had a very significant impact on Toyota's thinking. If you consider he was in there over like a 20-year period, teaching the P course, not only the P course, but also, there's a lot of thinking processes inside the Toyota production system. So that's what I've been digging through in the programs. Now, at the very beginning, a lot of people who start trying to do lean, you want to, the goal is creating pull and pull systems. And I want to make it clear that Ono considered pull a containment step. His ideal was to try to create flow. And so he flows where he can and he pulls where he can't. So you can look at this and begin to evaluate where you are in your system. Are you just really totally disorganized, no planning, just reactive? Or do you have a push system where you're just forcing material out into the production operation, regardless of whether you have space or capacity for it? Or have you actually begun to set up like a pull system? Now, it's going to be extremely difficult to create flow across a total organization. And I would say almost impossible, but that's an ideal. You can have flow between small groups of processes, and you mostly see this inside some of the cells that you can set up. So the next slide, and I think I've posted this on the group. The interesting thing is applying lean or trying to create flow really depends on your product mix, the volume that you're doing, basically, how complicated is it to get flow? How many people do you have? That sort of thing. So if you have fairly high volume, even though you have moderately high mix, you can still get a good bit of flow in a lot of operations. The job shop is a bit different, and the tools you'll use for, say, the job shop or the smaller shops are quite different than what you'll use in the standard tools when you're like Toyota, or if you have 1,000 employees and you have very high volume and you're shipping things in truckloads. What's open to you and available to you and the tools you use is very different. So like in a job shop, a lot of times you can use some things like group technology to help think about how you configure your layouts. And if anybody wants to go into that, we can. But there are lots of different tools we use inside to get to that point. Now, the other thing I want people to realize is the concept of flow actually has a fairly long history, several hundred years, actually. And in the beginning, we begin to do rationalization, where you work on trying to smooth the flow or simplify the process of individual processes. And over time, they begin to think about the whole factory as a machine itself. And even recently, you think about Tesla as being kind of an innovator, and especially even in their car manufacturing. And there's a nice little video of Elon Musk talking, and it's like 4 or 5 years ago when they were doing the Model 3 production, and he called it his production hell, where he was sleeping on the shop floor, and he had a kind of an epiphany about the difficulty of basically creating the machine that makes the machine, but he saw the possibilities of improvement, or the opportunity was just so much greater, and he was thinking that his capability was maybe in the 2 to 3% range of what was possible.
Hello.
Yes.
Guys, we got a loud person. I'll have to mute everybody if that doesn't stop.
मतलब 9 बजे भी चली थी जो आज 1 बजे चलनी थी
I
दिल्ली
think
से
we're muting.
वो अब कल सुबह के बाद चली 9:32 पे भी नहीं चली वो नहीं अगला टाइम आ गया 9 बजे
So
हमारे टाइम से
There's always one, isn't there? Okay,
okay,
let me just try to get that
Hey, we're here.
muted. Yeah, mute all except Mark.
Hey, Mark, you're muted. Can you unmute your microphone?
Trying to get Mark unmuted.
unmuted.
Are you good, Mark? Great. Everybody else is muted. Can you see there how to unmute yourself?
Unmute. Yep.
I can hear you. Right. That's good. Let's
Can
go.
everybody hear me? Okay.
Yeah.
Okay. So go back to the presentation mode. So by the turn of the century, people begin to understand about flow, and there are, 4 primary principles of flow, and everything in lean, everything you do toward creating flow follows one of these principles or all of the principles. So that can be a whole discussion altogether. But I think people want more than just philosophy.
Yeah, we do. Give us some
Yep.
non-philosophy. We like some, but not too much,
Okay.
Mark.
Okay. So the other piece would be and I'm thinking about the things that I read about Shingo and Ono, and they talked about there was a time in their practice of work that they had kind of an epiphany about, they started thinking about work differently. And not only they started thinking about work differently, but the people that they drew on to copy also had this same sort of epiphany. And I think a lot of people, when you transition into like the 2-second lean and like your improvement starts with I, it really requires you to make a thinking change about how you do things. And if anybody wants a list of stuff about some of the history about some of this thinking, here's a list of books. I can skip over that. Just send me a note. Now, the interesting piece is I want to try to kill the one-piece flow moniker. I've fought against it for 20 years, and finally, because I've gotten into all of Shingo's books and realized kind of where the source is and his discussions, we only have a little piece of the story behind it. It's not just one piece is an ideal for the flow part. Also, he wanted transportation to be 0. He wanted the cycle time to get as close to 0. He wanted delay, like the intermediate stock, to be 0. He wanted work in process to be close to 1 as possible, or as close to 1 as effective given the processes. And the critical piece was synchronization. And he talks about that. And he talks about getting rid of the delays. And he calls delays more stagnation, which makes you kind of think of things differently. And oh, by the way, the inspection cycle, like his 0 QC, you want the inspection of the poka-yoke to be inside the value adding time as much as possible. So he talks a lot about thinking about space and time. Space is your
So Mark, with this, like, just because I'll play the dumb guy, it's easy for me.
Yeah.
So one-piece flow, you're saying here that it's got like overemphasized
Yep.
over all the other goals that he had. So people obsess about one piece flow, or
Yep.
we've all
So,
seen it. And
so I've
really,
had that.
he had
Yeah.
these multiple goals.
Yep. So I've had that argument with several people, and when I try to explain them about flow, I said you either have flow or not flow. You don't, you're really handicapping yourself when you say one piece flow.
Uh-huh.
So it's either flow, and that's what Ono talked about his river system. You want things to run sequentially, with as much or as a little delay between each sequence of each process in the flow. And so that's the trick about the synchronization. And this is what TAC is about. So we've also basically screwed up on TAC as well. Yeah. So we're getting the cart before the horse when we talk about TAC. The piece about the TAC is the beat, the rhythm. What rhythm do we need to do to coordinate all the processes, not building up stock, not starving for stock?
So Mark, I got a question there.
Yeah.
I might try to unmute everybody again. Hopefully
Yeah.
the crying babies have gone away. But a question. So is tact appropriate in lower volume settings, in higher mix, lower volume settings? Do you still have tact? So, if I'm making something for talk's sake, if I make one thing that takes 20 minutes to put together and I make another thing that takes 3 days to put together, do I even bother trying to get tact in my facility? Or do I just try to put it in micro level? What's the answer to that one?
Well, you really want to break it up. It to a large degree, it depends on the repetition. Now, I helped actually set up a shop for Flow where their large batch was 5 pieces. And what we try to do is we try to get the process sequence to be very consistent. And this is one of the interesting stories that keeps recurring in Shingo's piece, where he goes in and he looks at a process and he says, okay, step 1, step 2, step 3, so the first 2 or 3 steps are very consistent in the number of seconds for the cycle, but there's one that has a big variance. It's like, and I'm going to get into this, it's what we call heat mapping. And so what you want to do is you want to say, okay, where do I have the most variation? So, why is it a variation? So there's actually some tools we can use to get into that.
Right. Awesome.
Okay.
By the way, guys, everybody can unmute themselves now. You don't have to, but if anybody wants to speak, we're back to anybody can just go for it, as the collegiate discussion that Mark was after. Okay, Mark.
Thanks, Tom. So, I like the feedback, the way you're doing it, making me clearly cover it. So the next thing I want people to think about is there's levels of granularity. So it's not only levels of granularity, but iterative. So I want to start out looking at a fairly high level and then work my way down. So like I would look, this one I was using as an example in a company I was working with in Asia.
Mark, I'm going to ask you to go back a step. Again, I'm doing this in the spirit of giving everybody a rounded understanding. So most of us on the call are 2-second lean people from our emphasis. This is really what I'm getting from that slide, is that the systems thinking is at the other end of that. This is where we're looking at the whole system, and we've different views, where most of us are down at the, in our, the very essence of 2-second lean in itself. And that's, if it's dogmatically applied, you're looking at lower, smaller ways, many subsystem, little improvements in 2 seconds, whereas this is the whole spectrum.
Yep. So I want you to kind of look at a high level and then work your way down. You can get, you can basically spend a ton of time making all these little improvements. It may fix what bugs you, may not, but the other piece is, since most of the people are probably working with smaller companies, and I can give you some statistics, is like in the US, 80% of manufacturing operations have less than 20 people. In Europe, it's like 90% have less than 20 people. Even though you see manufacturing of these monster companies, what do the small shops do? Well, you can use some of the tools that Toyota used, but it's not as effective as you think.
Mhm.
It's
Beautiful.
really difficult. Okay.
This is super interesting.
Okay. So I want you to think about, you need to get into your mind, what's the, at a high level, what are the kind of the, from like your supplier inside your factory and then your customers. I want you to look at, what are the barriers? I mean, and I'll get into that a little bit as well, but you can look at the high level, and then we can keep going down. And this was an example that I used in a job methods practice exercise to help people do process improvement, where we, put the people and we kind of did a layout, and we had people look at, okay, so what bugs them, what was hard, what was difficult. And we did a challenge exercise to do the improvement. But you can see right here at the bottom says like the wrap, the way, the bottle, so I've got the basic piece. And then
Process
we said,
flow.
okay,
Yep.
which one is most problematic? Well, that's the one I'm going to focus on. So ideally, what you want to do is in your very first pass, just like that. Well, let me go back up. Just like this, we've got like 5 operations, kind of generic. It's not detailed, it's just generic. We want to dig down. So which one's problematic? And I'm going to tell you, if you can't clearly see, or if you bring a visitor in and they cannot clearly see what the sequence is, it's so disorganized, then yeah, you really need to do a lot of 3S'ing. So, I mean, this was, and actually the 3S came out of the job methods in TWI, is you need to get organized a little bit, just enough to get basically your act together. So, but once you know that, then once you can kind of clearly see what the sequence is, and maybe you do a little bit of moving around, that sort of thing, I want you to go back and walk through those same pieces and list all of the problems that you have. What kind of activity, what kind of rework, machine malfunctions, bottlenecks. Once you identify your barriers, these disruptions are what actually eats up more time. And one of the observations I just stumbled on the other night, I was reading some of Shingo's stuff, is he talked about the improvements that you gain more from removing the barriers than you did from actually fixing a process. And I'm not saying.
Can you dive into that a bit more? You get more from removing the barriers and fixing the process.
Okay. So, well, maybe the fixing the process. I mean, so I'm not, let's say, let me back up. I maybe need to retract the fixing the process. So if I have a high rework rate, yeah, I need to do.
I actually think I get you. So if you've got a part of your process that's giving you 10% reject, that's a barrier, you can say. Taking that barrier out, well, automatically your throughput's going up at least 10% because you've got rid of that. So it's an easy place to focus.
Yep.
And
then sometimes, I mean, I've gone into places where high volume automatic machinery, you'll have the machine at a fairly rapid cycle time, and the machine will cycle and there won't be a product in there. So you have missed cycle times. So one of one of the things I look for is I'll walk through and I'll look for, do you have a embedded rework process? That tells me you have a process that's not capable. If you have a problem that's so common that you already have a standard process about how to address what didn't work right, you need to start fixing things. Or if you have a machine that doesn't function well or has high downtime, I mean, we can get back into the maintenance piece of it. So the next piece is I start looking at unnecessary activities. And a lot of people think about waste, and I'll give a little thing. Oh no, listed and actually only had 4 waste originally, and I think it's like 78. Anyhow, it was much later in the process that they got up to 7 waste, but originally it was only 4. And he quantified them because people were having a difficult time identifying true disruptions that could be fixed. And a waste is really an unnecessary activity that we're doing that we want to remove. And so that's our goal, is to try to remove the unnecessary activity. And some of that is, I mean, they've used this illustration several times. I mean, a lot of times I'll go through and I'll ask people, so how many times do you touch it? How many times do you pick it up, put it down, pick it up, put it down? One of the pieces inside flow is I'm trying to pick, and I would pick like 2 processes to start with that have maybe about the same rate. And I want to make sure those machines are as close together as possible. Well, the operator, as soon as they finish that operation, they set it down or put it into the fixture for the next operator. So you're beginning to synchronize 2 operations. So you don't touch it numbers of times. I mean, I went into one flooring operation and they were trying to improve the throughput, and they were getting their oak logs by rail, and it came in, and I asked them, can we improve that? Oh, it's not all that necessary. And I was like, well, how many times do you handle it? And we went out and started counting the number of times that they went through and moved that log. Was 9 times between the railroad car and before it got to the sawmill. And it was like, oh,
Just on an aside to that, some of you might have saw I did a lean tour of a local trailer manufacturer, SDC, and they reckoned by eliminating one store and moving another, they were taking 1.5 miles out of transportation out of every single trailer.
Yep.
It is that powerful. That's before they even start doing anything with it.
Yep. So a lot of this is like, okay, you're putting on a different set of glasses about how you see work. And the next one is, and I took these illustrations out of Toyota's manual as well. It's like, are you working or just babysitting a machine? And babysitting a machine often is a symptom that you have a process or a machine that's not that capable. And then I can show you ways of kind of drilling down and understanding what functionally is not working right that requires having a person sit there and watch the machine. So once I've got the process sequence, then I want to talk about velocity. And I want to challenge you, please don't try to do time studies. Don't get out a stopwatch. The first pass, go ask your operators, and I'm not sure, it depends on your product. It's like, so many pounds per hour, so many pieces per hour, some pieces per day, depends on the type. But what you want to do is you want to get just kind of an approximate value. And the reason I don't want you to get out a stopwatch, there's some psychological reasons that people feel like you're challenging them. But you want to be doing the improvements so rapidly. And in the early phases, you can do improvements so rapidly, you're wasting your time trying to document an accurate time study. If it's a fairly short cycle time, just, go out there and, get your watch out. I mean, you can get your watch out if you want, and just count like they did 10 pieces. How long does it take? Well, it takes about this. And as you're observing those 10 pieces, do some seem to take longer than others, which makes you go back iteratively back into problem solving. Why is one taking much longer than another? So here's an example I had from when I was doing a project over in Asia with some IE students at a company. I had them go out and do the same thing. Follow 10 pieces, tell me how many pieces per hour is the capacity of that particular station on the line, And they came back and they was like, okay, so this one can do, I can't quite read how many 100 per hour. And we put the target, basically the tact rate was this, the little dotted line. I'm not sure if you can see this or not.
Yeah, we can.
We could say, it's like, okay, so what are we going to focus on? And it became really obvious that I had overcapacity here, overcapacity there. Here's a couple that are under capacity, that one. So I've got 3 that are under capacity. So once I do that, I've identified those 3 are basically those are my bottleneck or weak spots of meeting production demand. And I went back, it's like, okay, so what am I trying to improve? You know, where I'm trying to find where the holes are and what am I going to fix? I mean, most as an engineer, I want to be really, smart and creative, and I want to invent something really new. And it's like, you have to put that on the back seat. If you look at it, generally the value adding part is a very small percentage of the total time. I mean, Toyota says maybe 2 or 3% of their total time in the car is value adding. Even Toyota.
Mind blowing.
Yep. So let's work on the really easy stuff first before we try to get into the more complex pieces. And if somebody has a difficulty in picking out what an activity is and you're focusing on just the work, but you also have, what are you doing to get ready? What are you doing, on the checking process? What do I have to do on the cleanup? I mean, the get ready and the cleanup is really big in the food industry and pharmaceutical industries. Some of the other delays that you can have are right over in here, just a difficult movement, having to walk. And when I'm looking at layouts, I usually don't try to get accurate measurements. All I do is, okay, how many steps do I take from process A to process B? Let's make it really simple, really easy. So once you've kind of picked out a problematic area, let's start going in. What one thing am I going to do that's going to make an impact? What am I going to change? And I like to use this slide. Management is going to measure you, or your pocketbook is going to measure you on the output, which is basically a symptom of your inputs and your processes. If you want to change anything, you've got to change something here or change something there. And it's really almost like a math formula. Okay. So this is a snapshot I took a couple of years ago for the pandemic, where I was doing a project at a packaging factory. We were trying to increase the flow, improve the flow of a packaging factory. And so the very first thing is, do you have a standard? And they actually they've been doing job instruction for several years. But even with that, we stumbled into areas where they were having difficulty that they had not done that. And so, do you want me to go into job instruction at all, or job breakdown?
Touch on it, Mark. Why not?
Okay. So, on the surface, it looks like it's just a training tool, but truly it's a structured method for organizing your thoughts and understanding clearly what is going on in the work. So the very first piece is you come down here. These are the important steps. Basically, this is where the value is added, and you'd say, and make it simple, object and an action. Don't write a novel, don't explain what you're doing, but just tell me, okay, what's this step? Then I put in that step, is there a key point? Is there anything in safety that I should do to ensure the safety of the operator, the safety of people downstream, the safety of people around me? Next, quality. What must I do to get the right outcome? I mean, basically the desired outcome to be able to move it to the next process. And the third piece is productivity. What can I do to make the job easier, quicker, faster, that sort of thing? Now, the next piece is you're not going to improve your knowledge until you can explain why you've identified any of these as key points. The nice thing about this is forcing yourself to think through each process step, what you're doing. Also, it never fails that people generate new ideas because they've actually broken down the job. And I tell them, okay, the focus is make no bad parts, make it easy. I want to remove all the waste, sort of piece. So, and I can share all these slides with everybody if they want to do that.
It's very interesting, Mark, because it's not the first time I've heard that, but it's actually given me an idea I'm going to talk about with the Gemba development team. Like if you could review our simple SOPs and subject them to a quality, safety, productivity review within the software. So you can, as a team, you just roughly document the process first. And then the next thing that if you want to, you can conduct a TWI review of each step. And it's prompting you to look for safety, quality, productivity, and then you can review it live back into the software. That'd be pretty nifty. So you've inspired me.
So the other piece is anytime you have a Kaizen, a key point, that is basically, that's like my secret list of things that I need to make easier and improve. It's like if you're hunting for how to improve or simplify things, the key point piece is this is the extra effort an operator must make to get a good outcome. How can I, how can I make a fixture?
If it's, for example, make sure that you're using 3 Newton meter torque. Well, how can I leave it that he doesn't need to make sure that he has a 3 Newton meter torque? Is that an example, that kind of thing?
Well, maybe not the exact torque, but I mean, the orientation or, or you have to hold it a certain way to, otherwise you'll scrap something. Or you have to be very careful to protect something, otherwise it's scrapped.
So the opportunities are in the care points because there's struggle there.
Yep, that's a good way of putting it. It's an opportunity section here. The other piece is you cannot do good improvement until you truly understand what goes on inside the job. So, so the other piece is I've used this. I try to take people out to practice hunting for problems. And another thing that we've gotten really wrong is the gimbal walk. Maybe I shouldn't go into that.
We'll restrict you. We'll give you 1 minute. Do it.
Okay. So the gimbal walk originally was the walk that the manager did with the supervisor. So the supervisor is kind of giving this is where we are. This is the things I'm facing, gave the information upstream to management. Management's making sure going downstream that the supervisor is going in the right direction. But at the same time, this is where the manager could say, my supervisor has a weakness on being able to define the work or teach people or solve problems or make improvements. So this was a people development process. Make sense?
Got it. 100%.
Okay.
Yeah. And it's like, even if we could just be more conscious about that. And I think as well, the key thing for Toyota in that situation, to be a manager, you'd had to have reached a level of understanding of the system so that you could coach, that you could
coach. Basically,
you're assess
coaching
and coach. If you can't assess and coach, you can't do this. You have to be fairly high level yourself.
Well, let me get out my pocket cards. Here's my cheat sheet. This is what I'm coaching. I'm making sure you're following the patterns. Oh, kata. Wait a minute. So we've basically turned the gimbal walk into industrial tourism rather than a coaching exercise. So here's the students again. This is a little bit more detail about what They did. So the first thing is I'm defining really what the work is to a good detail. Then I'm coming back and I'm defining what process step is the problem. And, so then I'm beginning to pick out which one that I want to solve. Which one should I work on first? Then I also can look at work in process. So for me, kind of red flags are operators being able to stack up work ahead of the next operator because they are so much faster. I mean, that's a giveaway. Or another operator struggling, sweating to try to keep up, which is, we think about the Mura, and it's the last one. It's the unreasonable thing of having a person struggle to keep up. That's where Ono started first. He didn't start with the waste. He started with the unreasonable activity first. So I'm looking at not only the volume that you have stacked in between it, and I think of inventory, intermediate inventory is like insurance. People put basically insurance or buffers inside an area because they know they have, lots of variation. They know they're trying to basically hide barriers or problems in the process.
I love that, by the way. That was a real moment. Odo didn't look for waste. He looked first for unreasonable activity.
Yep.
That is so cool. It's like basically look for struggle.
Yeah. So if you look for struggle, I mean, you think about respect for people. You don't want to put that struggle, unreasonable safety risk, on the operator. If you do that first, then things will be, be very, very quick. So once you've understood it, then you can challenge it. Now, I can, a lot of people really like this as kind of a good challenge piece. So once you clearly understand all the pieces, then you can say, okay, how do I challenge it? This is where your Kaizen, your improvement piece comes in. Tell people, don't focus on speeding up the process. Start. I mean, you get all sorts of enmity. I mean, if you go in, when I go into bigger companies, that's always been the fear is, I guess they call it work intensification. I'm going to force people to work harder, faster, no breaks. I mean, this is a complaint with like inside Amazon, is they're basically working people to death. So I want you to focus on basically removing the quality problems, sorting, rework, adjustments, remove non-value added materials. Is it necessary? Challenge it. What's the purpose? It's easier to remove something than it is to improve it. Then I want you to, count the number of times you pick it up. Then focus on trying to make it easy for the operator. So at a high level, when I go in, I try to make sure the process is capable and I'm getting everybody to follow the standard. Once I get a functional process, I also go back and say, I want to make that, I've got the process working properly. How can I make it easier for the people? And then once I make it easier for the people, how can I basically improve the process, make it more efficient and more effective? So I'm just going to put some slides up. This is kind of an ideal cycle. So what I've talked you through is I want you to walk through and kind of develop an awareness and basically discover the flow, define your standards, challenge them, and then improve. And it's just once you've made a change, and then it also changes what your flow is. So you have to just cycle, and it's just very much an iterative process. And if you want to know kind of basically what you do at each one of these, I've got another layer of things. Then let me go back and talk a little bit about Shingo again. And I know if anybody's read any of his books, they're regularly see this little matrix that he has. And he actually has been trying to discuss this since the 1950s. And he talks about organizing things in space and time. And so the space is basically the footprint of the operation, and the time is the actual cycle times. And you're trying to smooth things out. So if you guys would do a 2% target, not the 2-second lean, but a 2%, think about what one thing can I do in the system to improve 2% productivity each week, you'll achieve roughly a 3 times input in a year. So, Tom, do you want me to go over some of the principles?
I think, well, is
Oh.
that what you were planning to present, Mark?
Yeah, pretty much. I mean, I'm
'Cause-
wanting questions because I can talk
Yeah.
through the principles of
I
flow.
love this. Like, I think you've done a great job of outlining what is your thought process and how do you approach understanding flow. I think that's, we talked about how to improve flow. You first of all have to understand it, as you've
Yep.
really clearly laid that out, and
Yep.
then what your thought process is towards getting it better. I think, yeah, let's open up for questions. We're going to unmute all. Let's see how that goes.
So,
Actually,
okay.
you can all unmute yourselves if you have a question. We had one question, I think it was from Nicholas. But I think we'll open it up to the floor first, but we would definitely won't forget Nicholas's question.
Okay. Go ahead, guys. Ask me. I know I've kind of dumped on you a little bit. I mean, I can tell you stories where we double production in 90 days or less.
Mm-hmm.
I
I'm mostly, because I think most of the people on the call are coming from high mix, low volume environments.
Yep.
And I'm interested in hearing that, anecdotes and stories from that environment. And yeah, do you want to shed some light on that?
Okay. So, well, the first piece is you do the high level flow. You look at what some of the barriers are. You look at where some of the high variation in some of the processes are. Sometimes it's distance. Sometimes it's overproduction in one area, waiting and starvation in another area. Some of it we end up putting carts. So in Canada, there was a small operation. I'm trying to remember, gosh, this has been 20 years ago. They made fuel tanks.
Mm-hmm.
They made the fancy extra fuel tanks for the trucks. You see the big polished aluminum fuel tanks going on your trucks going down the road that have a couple of 100 gallons. So they made aluminum fuel tanks. They made just a plain metal fuel tank for the railroad car diesel cooling units. But anyway, so they had 3 different materials that they used, and they were struggling. And some of it was in the welding, and some of it was sometimes the welders wouldn't have materials. Sometimes they would have, basically stock outs. So some of it we did in tooling. One of the tank welding operations, we added a small jib crane. So instead of having a 2-man operation where you have to interrupt one welder to come help and move and turn things around, it's now a 1-man operation. Then we made up carts that the person making the cuts and the basically some of the rolling of the materials, that cart was a kit for a whole tank.
I think,
Yep.
Mark,
Yep.
what I'm hearing from that anecdote is, honestly, the approach is the same.
Yeah.
Yeah, the approach is the same. We're there to remove barriers
Yep.
and to follow that process, whether it's a shop that makes one thing every day or the same, or whether we're doing 20 different things every day. The process is still the approach is still the same. Thankfully now, we've managed to unmute people who want to be unmuted. Who wants to, does anybody have a question for Mark?
Maybe I would start first. I just want to support Mark on the thing he said about quality. I mean, I have experience in my company that last year we really, I decided that we should focus just on quality, and the result is amazing. You know, I mean, the amount of rework. I mean, we are in mode making business, and the rework is since we are doing everything in hundreds, really precise sync and so on. We really did really good job last year. I know by myself, but just focusing on quality. So every operator, every program, everyone focused on work and checking their own work. This was really good result. Yes, that's all.
Mm-hmm. Any others? Thank you, Hugo.
Yeah. So I can give him an example. So I don't know if any of you track OEE.
Used to, long time ago. Overall equipment effectiveness, for those who aren't aware.
Yep. So on a light bulb production line where they run basically two parallel lines, has roughly a 3-second cycle time. Their typical production was 8 to 10,000 pieces a day. And by focusing on, we started with job instruction to analyze exactly what each operator was doing. And we even used it on the automation to basically problem solve and figure out what the automation was. We increased the OEE to 98 to 99% and went to roughly 20,000 pieces a day. Now, world class is about 80% OEE. And they went far beyond that. And it took them over a year, but it's 1,000 little improvements that did that. I mean, I can talk about a smaller shop.
There's a question there for a suggestion from Drew Dolphing. Mark, you instructed us to move our more intricate molds away from our less intricate mold line, telling a story about door and window manufacturing. This has been a big improvement for us, and I think is something the group would benefit from hearing about. Do you want to let us know about that one?
Okay, so when you're in this, there's a thing called ABC analysis, and a lot of you may have seen so you go and you rank all the things that you do, and you can put them on a Pareto chart, and you have things that are fairly high volume, and those are very consistent. Those are the ones where I want to try to get a standard first. Then the next ones, so they call those runners. Those are very much
runners, repeaters, strangers. Is that what you're talking about? Yeah.
So how I approach, I want to master the runners first. Then I start mastering the repeaters. And sometimes what you end up doing is setting up multiple cells. And if I'm talking about cells or like the mini factories, the OC Tanner group.
Mm-hmm. Yeah, we're aware of them. That we've recently been talking about them in the group.
Okay, so I started working with them 20 years ago. So I mean, I started them on the TWI stuff. So
you say that like a proud grandfather.
Oh no, that's just. Well, I've got another one where high volume. We're using the same footprint, about the same number of people, and in 5 years, we're putting out 10 times the volume of product. Oh, and quality's up too.
I think, again, I just want to try to tailor this for the group we got. When Mark's talking about the runner, repeater, stranger thing, I think it really applies in most of the businesses that are on this call. So you've got your runners, which you're seeing most days or every day, and they're decent volume, and they probably account for a good lump of your sales. Then you got your repeaters that you're seeing every week or two or month or two, strangers now and again. And like when you're focusing on the runners first, you're obviously going to have the highest impact, and they're going to have the highest profile within the business as well for the people in the business. So it's it's a highly logical approach. So even within your one facility, you'll have like one runner could have a different tack time from another runner, I would imagine. Obviously, is that a fairly obvious statement? So, yep. So is that fair to say, Mark?
Yep. And so I can take that same runner repeater strangers to activities. Now there's a factory down in Mexico that makes precision items, and like I said, their goal was, their high volume piece was 5 pieces. Most of the time, it's like one of this, one of that, one of another. It's like, okay, so everything's almost strangers. How do I approach that? Like, okay, so what is common activity? Oh, well, I have
love
to.
it.
So we basically turn it on its head and still use that same thinking process. Now, group technology says, okay, you start doing the routings. You take your runners and repeaters and say, okay, what machines, what processes do they go through? Then you make up a matrix. Which ones follow the fairly common steps? I mean, what's the well-worn path?
Mm-hmm.
If I get 3 steps to 5 steps in sequence that are very common, I make a cell out of that. So I'll bring that product in and go bump, bump, bump through the operation. And for you making you're making some circuit boards or whatever, you have it set up to make circuit boards. I mean, there's
So
a set of
like
steps.
even within my own industrial past at O'Lear, people have heard about in the book, our runners had a line which we put on basically a pallet of component went on it. They're very big components, and it went on a roller track through the fixed sequence every time, and we automated some of those steps that we could when you had some sufficient quantity. We couldn't do that on the repeaters and the strangers, but we physically had an area for the runners, and we physically had an area for the repeater stranger part, because even physically the flow doesn't work because you've got your different frequencies of movement happening, and if you're doing them all in one area, it just doesn't work. So even physically segregating the runner from the repeater and the stranger really had a massive impact on how you managed the material and the distances involved with the runner versus what you maybe could and what was available to you on the repeater was very different.
Yep. So I mean, when you're thinking about the process, you can go in. It's like, which 2 steps can I put closest together and synchronize? Then maybe add a 3rd step, synchronize those. That's your little flow piece. And
that's really mind blowing. Here,
and
sorry, I'm only going because of time rations for everybody.
okay.
I think we'll make this, maybe do another one in 2 weeks if everybody's up for the special U mark. And we could do this, and we can have another short training and another longer extended chat. And maybe this time, if we're giving it a little bit more distance, people can be prepared with their questions in advance, maybe.
Okay.
That's another idea, but just to try to improve it for next time. But let's take 5 more minutes. Nicholas had one question. I want to do him the courtesy of asking you, Mark.
Okay.
Ono said that everybody should be a tortoise, not a hare. What did he mean by that?
Sometimes, and OC Tanner has a couple of perfect examples. Sometimes slowing an operation down actually speeds up the system. So they have a stamping operation, which the cycle time is a fraction of a second. Normally in big stamping operations, they stretch it out to almost 2 minutes to match the synchronization of the other steps, and went from this big stamping piece to this small air over hydraulic press. And they also totally changed their die. So it's basically it's a one touch die system. And for people who are in job shops, your setup, changeover, takedown, cleanup kind of stuff often takes far longer than the operation itself. So maybe we should talk about the SMED, except, and reading Shingo's books, he talks about setup reduction is only an intermediate step to his goal. And I'm looking through all the English translations. They've got one page that lists a couple of items about this one touch, and that's it. There's nothing there that in English that people are explaining what his ideal goal was.
It's,
How to get there.
that's pretty. It explains a lot, in my opinion.
Yep.
Because like in my early part of my career, first 10 years were automotive, and I remember going to a Denso. One company I was supplying Denso, and I went to a supplier conference, and they were showing the European and American PPM, parts per million stats, versus Japan, and it was literally a factor of 10
Yep.
worse in Europe and America. And I think what's happened, and you're helping me understand this at least, that the version we have here in the West has lost so much in translation.
Yep.
Even within the actual organizations themselves. I'm talking even within Toyota.
Yep.
That's happened.
And when I released the Toyota's original manual,
Mm-hmm.
the guy who was the basically over the Toyota research group in England for like 15 years wrote me, he's like, thank you for doing this. I've never seen this copy. And
Mm-hmm.
so even inside Toyota, they don't
Exactly.
share.
I really got that feeling because
Yep.
the Japanese are operating at a whole other level. And so, look, I had a question from Nick Murphy. Hey, Nick,
Yep.
great to hear from you. Would Mark be open to sharing his slides after the conversation?
Yep, I can send this. I mean,
If you give it to me, Mark, I'll put it on Dropbox and I'll put it as a link on the YouTube video so people can just take it off my Dropbox.
Okay, so I sent you a PDF of the slides.
Yeah, awesome. I'll just put it on Dropbox and add it as a comment pinned to the top of the YouTube video.
So not knowing as much about lean in 84 or 85 when I was working for Cummins Engine Company, we had a very similar thing we had a crank gear press. We had 3 different crankshafts that we were pressing the gear on. Changeover time was over 2 hours. 2 hours if it's good. My goal as the engineer was how can I get that down to where I can do it inside the 60-second cycle time? I've got to actually press the gear on, pick up the crank, press it, get the gear, put it on, press it on, put it back out, and change from 4-cylinder to 6-cylinder to B series to C series. And I got it down within about 3 seconds.
Woof.
And I didn't even know anything about Shingo at that time. But
well,
I mean,
that maybe takes us on to our next
process.
subject. Do we? I'm going to throw it out there to the group. It feels to me like SMED comes after this. Would that be wrong, Mark? Would just exploring SMED, some principles, be a good next protocol?
Yep, we can. And because it actually goes far beyond just the die change. I can show you where I've done like 30 station lines in like 5 minutes or less. The whole, from changing from one product to the next product.
Yeah.
Shift.
Personally, I'd love to hear a deep insight into SMED. I've had surface training a couple of times in my career. I just have a feeling that you can offer us some insights that I definitely haven't heard before. So unless anybody strongly objects, let's do that next time.
Well, the other piece is everybody has my access on Signal, and you can put up my email as well. So questions, or request for in-depth, just tell me what you want.
I'll actually post an invitation to the Signal group. I'm okay with that on YouTube. I don't want to put your email address on there because you don't know what people might do.
Yeah, I don't want garbage.
Yeah, so I'll put a link to the Signal group in the comment section, as well as the PDF to download.
Okay.
But hey, I'm going to draw it to a close, guys, unless anybody has a burning problem. But hey, that was just Mark. Honestly, that was just so fantastic. My mind is totally blown. I've had so many aha moments. I'm probably speaking for the rest of the group, I have a feeling. Thank you so much for doing that. And thanks everybody for attending and making it feel like this was worthwhile for us to put together. I'm very grateful to all of you, but especially Mark.
All right. Thanks, guys.
Have a good weekend, everybody.
And I'm still a learner as well.
And we all are.
All right.
Have a great one, guys. Thank you.
Yep.